In today's video, we're going to explore the special relationships among sides and angles inside isosceles and equilateral triangles. Before we get into that though, we need to discuss what an isosceles triangle is and some of the vocabulary around them. An isosceles triangle is a triangle with at least two congruent sides. Those two sides are called the legs. The legs are the congruent sides in an isosceles triangle. The third side is called the base. That's the non-congruent side. The base angles are the two angles that are adjacent to the base of the triangle. In this triangle, in this isosceles triangle ABC, the two base angles are angle 1 and angle 2. The vertex angle is opposite the base. The vertex angle in this triangle is angle 3. So now let's talk the isosceles triangle theorem. The isosceles triangle theorem says if two sides of a triangle are congruent, then the two angles opposite those triangles are congruent. So I have it here in pictures. If two sides of a triangle are congruent, then the angles opposite those two sides are also congruent. The reverse of this is also true. If two angles are congruent, then we know that the triangle is isosceles. So if our two base angles are the same, then our two legs are also congruent. Now we can extend this to a third side called the equilateral triangle theorem. Let's get two quick definitions before we write this one down. So an equilateral triangle is a triangle where all three sides are congruent. An equiangular triangle is a triangle where all three angles are congruent. So if we extend our isosceles triangle theorem, it says if we have two congruent sides, then we have two congruent angles. If we extend it to three sides, and if we have an equilateral triangle, then it is equiangular. In pictures, what this means is that if we have three congruent sides, then we also have three congruent angles. And again, we can reverse this. The opposite is also true. If we start with all three angles are the same, then all three sides are also the same. So ultimately, key takeaway in triangles, if sides are congruent, the angles opposite them are also congruent, and vice versa. So let's look at a couple of examples. We have a couple of isosceles triangles and one equiangular. So let's start with this triangle TRS. I've got two congruent sides. TR is congruent to TS. Now the isosceles triangle theorem says that angles opposite congruent sides are also congruent. So angle R is congruent to angle S. That just means I can copy that X over here to over there. And then if I need to find what X is, we already know all three angles of a triangle add up to 180 degrees. So I'll add all three, set it equal to 180, gives us 5x is equal to 180. So x is equal to 36. We could plug x in to double check our angle measures. Angle R is 36 degrees. Angle S is 36 degrees. And angle T is 3 times 36, which is 108 degrees. If we look over at triangle PQR, we have the same idea going. We've got isosceles triangles. So the angles opposite the congruent sides are congruent. Angle P is congruent to angle Q. So that means I can copy that 3x plus 3 over from angle Q to angle P. And again, all three angles add up to 180 degrees. So 3x plus 3 plus 3x plus 3 plus 5x minus 2 is 180 degrees. Now we can go through, kind of combine our like terms, solve for x. That is 11x plus 4 is equal to 180. Subtract 4 from both sides. Divide both sides by 11 and x is equal to 16. Again, you could plug x in to double check. 3 times 16 is 48. 48 plus 3 is 51. So each of these two angles are 51 degrees. And then 5 times 16 is 80. 80 minus 2 is 78 degrees. And finally, we'll use this idea in reverse. If all of the angles in a triangle are congruent, that means all of the sides are congruent. That means the length of AB is the same as the length of BC is the same as the length of AC. So we can set the side lengths equal to each other because we know that these sides are congruent. And then we'll just rearrange so we can solve for y. First, I'm going to add the 1 over. And then I'm going to subtract 3/10 y from both sides of this equation. 4/5 is 8/10. So 8/10 minus 3/10 is 5/10 y. 5/10 y, 5 over 10 reduces to 1 over 2. So if 10 is equal to half a y is equal to 20. Thanks for watching.